Hi everybody, this is the latent heat of vaporization, latent heat of fusion notes. And sorry about the first video giving you so much sound trouble. Hopefully this one's working better. I want to talk about this first one here. If you just look at this chart, you have temperature on the side. You have the amount of heat that you're going to add down here on the bottom. And I know it's a little bit hard to read, but if you look at number one, it says how much energy does it take to take 2 grams of 100-degree water to 100-degree steam. We're going to use a weird formula for this. Instead of using MCAT, we're going to use something called MLV. That stands for the latent heat of vaporization. Now, if you look right here, here is 100-degree water, and this whole line right here, it stays at 100 degrees until you add 540 calories, it then changes the steam. So it takes 540 calories just to change 1 gram of water into 1 gram of steam. So if that's the case, I'm going to put in 2 grams down here with mass. The latent heat of vaporization is 540. So you have to just know that, calories per gram. So it takes 540 calories to turn every gram of water into steam. And so that gives you 1,080 calories, because the grams cancel out. And that's how many calories it takes just to change 2 grams of water into 2 grams of steam. Now we also have to look at how much energy is lost if we're going to go and take 2 grams of water and turn it into ice. But instead of vaporizing it, now we're going to be fusing it. So I'm going to use the latent heat of fusion, or some people call it the latent heat of freezing. It's fusion here. Once again, I'm going to have 2 grams. But if you look at the chart up here, it doesn't take 540 calories to do that. It only takes 80. So here is 0-degree water. Here is 0-degree ice. So that if you take away 80 calories, you end up getting the latent heat of fusion. So 2 grams times 80 calories per gram ends up giving you 160 calories. It's actually a negative because you're actually losing those calories. If you look at number 3 here, it says how much energy does it take to change 10 grams of negative 20-degree ice to water? Well, you're going to use a combination of formulas for this one. So I've got to figure out how much energy does it take just to raise the temperature from ice to ice. Now here's what I mean by that. This is going to be a negative 20-degree ice. This is going to be 0-degree ice. Then I'm going to need to figure out how much energy does it take to change the 0-degree ice into 0-degree water. That's a phase change. And then you're going to add how much energy it takes to go from 0-degree water all the way up to 30-degree water. That's not a phase change. So the formulas we're going to use here is this. For the part just to go from ice to ice, I'm going to use MCAT. For the part to go from ice to water, since that's a phase change and it's the latent heat of fusion, I'm going to use MLF. And then to go from water to water, that's not a phase change, so I'm going to go back to using MCAT again. So now we just plug in the numbers. Well, it's 10 grams. Now, this C right here, I guess I should be using green. So this is 10 grams. This C right here, that's ice. So I can't use 1. The specific heat of ice is actually 0.5 calories. And the final temperature minus the initial temperature is your change in temperature. So the final temperature was 0 minus the negative 20 that you started off with. Then you come over here for the phase change. Well, once again, it was 10 grams, not 20 grams, but 10 grams. The latent heat of fusion is 80. And we got that from up here. And then to do the water to water, I'm going to put in 10 grams. The specific heat of water is 1. And the temperature change, the final temperature was 30. The original temperature was 0. And so when you put all this together, let's see. Half of 20 is 10. 10 times 10 is 100. So it's 100. Plus 10 times 80, which is 800. Plus 10 times 30, which is 300. So you end up getting 1,200 calories just to change that negative 20-degree ice into 30-degree water. The last one, it's really complicated because you have 2 phase changes and 3 temperature changes. So we're going to do the same thing we did up here. But now we have to go from ice to ice. Then you have to melt the ice into water. I'm just going to put H2O to save room. Then I'm going to take the water and heat it to 100-degree water. And then I'm going to change the water to steam. And then I'm going to change the temperature of the steam. So steam to steam. Let's go through and figure out what all these are going to be. The first one, ice to ice, once again, it's going to be MCAT because you're not changing the phase, so MC delta T. The next one to go from ice to water is a phase change, and since it deals with ice, I'm going to use MLF. The next one goes from water to water. It's not a phase change, so I'm back to MCAT. The next one goes from steam to water to steam, rather, so that's a phase change. I'm going to use MLV because that's vaporization. And then the last one, once again, is not a phase change, so I'm going to use MCAT again. And now we just got to plug in a bunch of numbers. So once again, the mass is always 20. So I'm going to put in delta Q equals 20. Now once again, the specific heat of ice here is 0.5. It's not 1. The temperature, it started out at negative 10. And the final temperature was 0, so I'm going to have 0 minus a negative 10. Now we got to do the latent heat of fusion. So again, our mass was 20. Latent heat of fusion is 80. You come over here and do the one where you're changing the temperature of the water. So I got 20 grams. Once again, the specific heat of water is 1. The final temperature was 100. The initial temperature was 0. We went from freezing water all the way up to boiling water. Then I got to take it and change the phase of it. Well, 20 grams. The latent heat of vaporization, once again, was 540. We got that from the first problem we did today. And then we have the mass of the steam was 20. Now, the specific heat of steam, once again, is not 1. It's back to a 0.5, just like ice was. And our final temperature was going to be 110. And our original temperature was 100, because you can't have anything less than 100 degree steam. So now we just add all these together. Well, 20 times 0.5 is 10. 10 times 10 is 100. Then you have 20 times 80 gives you 1,600. Then you have 20 times 100 gives you 2,000. Then you have 20 times 540. That gives you, let's say here, about 1080, something like that. I think it's 10,800 rather. And then finally, half of 20 is 10. 10 times 10 is 100 again. And so when you put all this together, you end up getting 14,600 calories. Hopefully, once again, notice the problems are long, but they're just very, very simple ones, simple steps over and over and over again. Hope this helps you out, and it's a better quality video than the first one I put on there. Have a great day. See ya. Bye.